Okay, welcome back. And so today we're going to continue on. We're going to introduce two theorems that are going to help us to factor and solve other types of problems that we're going to work on next. And so the first couple of problems, the first theorem is called the fundamental theorem of algebra. And so the fundamental theorem of algebra says that every function defined by a polynomial of degree 1 or more has at least one complex root. So again, what the fundamental theorem of algebra says that any polynomial of degree 1 or more has at least one complex zero. That means that pretty much any such polynomial can be factored. That's what this is saying. So if it contains at least one complex zero, then it can be factored. Okay? So that, now what happened, what does that mean? It means from the factor theorem, remember the factor theorem. What did the factor theorem say? The factor theorem said that, hey, if f of k, if k1, or some k value is a zero, right? If k is a zero, then we can factor the polynomial, and we can factor it into x minus k, right, has a linear factor, times some quotient, right? Well, this quotient function is going to have a degree of 1 or more, right? Well, then we could do, let's call this k1, right? Well, we could do the process again for this one. So the fundamental theorem of algebra says, hey, this is factorable, so there has to be a complex value for this one. Well, let's call that k2. And so that means we can write this as x minus k1 times x minus k2 times, let's call it, p sub x. Okay? And so using the fundamental theorem of algebra and the factor theorem, we can keep doing this until we get down to the last factor, which is going to be a linear factor. That leads us, this repeated process leads us to the second theorem, which is the number of zeros theorem. And the number of the zeros theorem says that a function defined by a polynomial of degree n has at most n distinct zeros. Okay? And that's the two theorems that we're going to use. So the fundamental theorem of algebra says, hey, any polynomial function that's a degree 1 or more has at least one complex root, one complex zero. The number of zeros theorem says a function defined by a degree n has at most n distinct zeros. Okay, and we're going to use those in the following examples. That's it. Have a great day.